Hi everyone, I want to show you the solution to the homework. So in this homework we needed to do the same thing as in the lectures, just for a different dataset. So we use the same New York taxi dataset, but instead of green taxi trip records we use this for hire vehicle trip records. So we just go here and we download this data for January and February. So I'll just copy link address and then download this to the data folder. So I'll use our MLOps Zoomcamp, and then I'll go to the first unit for the first module, and I will download this to the data folder. So this is January and this is February. So now we have all this data. Now I'll import pandas, spd, and then I'll need to read the data for January. Spd read parquet, and then it's data, this one, we'll call it dataframe. So now we can see how many records are in the data frame. So this is this option. Next we need to compute the duration. And actually let me open the notebook we used for for the lectures. So this one, because I just want to reuse some of the things from here, because what we need to do is just do this. And yeah, here data frame head, the feature names are a bit different, so we need to change them a little bit. And yeah, I think, yeah, like that. Another option, I think it's even faster. Maybe I saw that one of the students actually did it this way. So let me show you that I think it's a better option. So I'll execute this thing first, and then now we have this data frame duration, and then there is this field called DT, date time, and this is a convenient way to access all the methods from date time, right? And this is how we do, and this is, you notice it's a lot faster than what we had previously, right? And then I can just divide it by 60, and then it's much faster than just applying this lambda here. And yeah, let me write it here like this. So this will be the code for this, for computing duration. So let me just execute it one more time. So yeah, you see it's much faster. Yeah, and then we need to compute the average trip duration in January. So for that, we just do data frame duration min, and we get the answer, which is 19 minutes. This one, right? Okay, next one, we need to check the distribution. So to check the distribution, we can use the same function as previously. So remember, we used this as this one, the one from Seaborn. So this one, and in Seaborn there's this convenient function distplot. I don't know why they decided to deprecate it. It is very convenient. And then we will see now that, you know, that's like all the data is here, and then there is long tail, and there was apparently there was one trip that was 400,000 minutes. Yeah, that's probably a data issue. So we want to remove all these things. And yeah, let me find this piece of code where we removed. So this is what we used for removing. And I'll just add it here. And this is like a bonus question, like how many records did we drop? So we can see actually, so first we can see the length. We used to see it here, length, right? So this is the old length. We can write it to a variable, and now we can see how many records we will drop if we do something like this. We can just do sum, and we can take this value, this one, and divide. So like when we drop, to see how many of them we will drop is like we will drop almost 4%, or yeah, or like to actually see how many we will drop, we can do something like this, right? So this is how many we will drop. So let's drop them. I'll just again copy paste the same piece of code, and I will remove this. So now we have our data frame, and the next one is missing values. So there are quite a few missing values we can see using this isNull method. So it returns true if a value is missing, and then we can just see sum and see how many of them are missing. And the question was asking about the fraction, and we can simply find out the fraction by dividing it by the total length. And that's one way, or we can do mean. Oops. Right, then that's another way. And the question was asked for pick application ID. Pick application ID is missing in 83% of cases. Right. So quite a lot. And actually the question was asking, like, what we need to do here is replace the missing values with -1. So let's do that. So we'll select, let me just quickly do this. So these are the column names, pick application ID and drop off location ID, and we'll do something like fill NA -1, and then we'll write it back like that. Okay, so it's complaining because actually, so here we did like a copy, like it's a view actually, because we did filter. To avoid this warning, we can do a copy first. So let me read it again, and then execute this one again, and then execute this one. And now when I do this, there is no warning. Okay, so now we replace this value with -1, and actually it's still float. I wanted to also make it an integer, so let me also do this as int, or as type, sorry, as type int. So then it looks like actually an integer, but I will chain them. So next time when, for example, you execute this notebook, you just execute this thing once, right? Okay, so now we replaced it with -1, and what I can even make it even simpler, categorical. So just write this to a variable and then put it here. I think this is how we did this in the lecture. So next we need to use one-hot encoding, and we will use only this pickup and drop-off location ID. Yeah, so we need to turn our data frame into a list of dictionaries, then feed the dictionary vectorizer and get the feature matrix from this. I will just copy this thing, put it here. I don't think we will need this, and I'll clean it a little bit. I'll remove this head, I'll remove this plot, I'll remove the head again, and I'll put this at the top. Yeah, now it's a bit cleaner. Okay, what I actually need to do one hot encoding, right? So first I'll do train dictionaries. This will be data frame categorical. That's actually all the features we use. We do not need to use numerical features because we will use only these two features for our model. So to dictionary and orient records. Yeah, it's not defined. Let me execute this. Now, category. I think I have a typo here. Yeah, like that. Sorry about that. Okay. Now let's take a look at the first 10. Yeah, so this is how it looks like. Cool. And fit dictionary vectorizer. So then we have dictionary vectorizer. With dictionary vectorizer, and we do it will be xtrain, which is dictionary vectorizer fit transform, and we will fit that transform. And to get the dimensionality, this is what the question is asking, we do shape. We look at the shape, and this is the number. Yeah, of course, I do. This is not correct answer. I put this here on purpose to get this to be able to capture this mistake, right? So what I forgot to do is to turn this into a string. So we need to do this. So let me just do it here as type string. I think I have a typo everywhere, right? So I'll replace it here. And now if I do data frame head, yeah, I of course don't see it here, but if I do dtypes, it's object. So right now dictionary vectorizer should work differently. Yeah, now at 525. So now we have this option, right? Okay, so we have this option. Another way to find out dimensionality would be in dictionary vectorizer. We have these feature names, so we can just check the length of this thing. That would also give the dimensionality. And then we train the model. So we need to train a plain linear regression with default parameters, and then we need to calculate RMSE on train data. So let's do this. I think I already imported linear regression, and then we do linear regression fit. So xtrain, we don't have ytrain. Ytrain would be data frame duration values. Ytrain, and now we do, to calculate RMSE, we do linear regression predict xtrain, and we use this mean squared error to see what is the actual ytrain, what's the error, and we need to do squared false, and this gives us 10 minutes of error. So this one is the correct option. And now we need to answer the next question. When we need to evaluate the model on the validation dataset on February, we need to redo everything we did so far. So I will just copy everything. Maybe I just need to put this in a function. So read data file name. So data frame, this will be file name. So the next thing that I need to do is filtering. Then after that we, yeah, of course I need to also compute the duration. This one. So I'll put categorical outside so I have access to this variable later. And then also I need this as type string, right? And I think that's all the pre-processing we need to do. I hope I didn't forget anything. I think it looks correct. So it will be data frame validation. I do read data, this one. And let me look at D types. Yeah, the D types look correct. We have duration, we have pick application ID, drop off application ID. So let me just turn this into dictionaries. So I'll call it validation dictionaries. And then we need, of course, this one. And yeah, so here we do not fit it, we only transform. We transform this and this. And now we just need to apply our model. So we apply to validation dataset. And now we need to get our Y validation, of course, as well. So this would be data frame validation. And now we compute this thing. So like that. And it is 11. And this is the answer we have. Yeah, so I am saving it right now. Of course, this is a very sloppy notebook, but I will not change it. So you will see in the future modules how we can make it nicer. But the main purpose of this homework was to prepare all the environment and revise the main concepts from machine learning, which we did here. So we have the environment and we see how to feed a model. Yeah, so that's all from this homework. I hope you enjoyed it and see you soon in module 2. Bye.